All right, this is review 13. We're looking at problems 9 through 13. So on 9, we have the graph of the function g is shown on the grid. Find the value of the y-intercept g. So with this, if I've got a nice pretty point, which I'm pretty sure I do here, I can see that that's 0, -8, then I can work there. The other thing is you can use stat with the two equations that they have. So if you go ahead and put those in a table, then you can use stat and get the equation from that. And remember that whatever you get on the end, so I should have y equals something x plus 8, or sorry, minus 8. That again is your y-intercept. But here's the thing, it wants the value of the y-intercept. And this is one of those ones that's going to have the grid. With that, the value is talking about the y value of it. So I'm just focusing on -8. So my answer that I would bubble in is just -8, because that is the value of your y-intercept. 10, we have the quadratic equation in vertex form, can be represented by the graph with a vertex at -2, that passes through the point for -67. Okay, so with this one, I know my vertex is HK. I know my vertex formula is y equals, which again, this is from my formula card, y equals a times x minus h squared plus k. So that means that I need the opposite of my h. So I want opposite of -2. So I don't want B and I don't want C. K is going to stay exactly the same. So then I want +5, which means bye-bye A, bye-bye C. So D is the only one that match. If you have one that has different A values, remember that you can go look at the table to see which one has 4, -67. With 11, we want the equation in slope-intercept form. Well, hey, I can do that straight from it. I just need to find my slope and to find my y-intercept. So my y-intercept is right there at 0, 2, and then I can kind of count from there, down to right 3, down to right 3. So when I go down to right 3, that gives me my slope. So I have my equation as y equals -2/3 x plus 2. Number 12, Kiki bought 7 items for lunch that cost a total of $14.55. A piece of chicken cost $10.10 each, and apples cost 75 cents each. Which of these systems of equations could be used to determine C, the number of chicken pieces, and A, the number of apples Kiki bought for lunch? So I'm seeing two totals in here. I'm seeing a total of 7 items, and I'm seeing a total of $14.55. So I want to go check that those are the totals on both my equations. Okay, so that means G's out because it's only got $14.55. J's out because it's only got 7. So now I'm down to just F and H. So if I'm looking at how many items I have, well, I have 2 different items. I have chicken and I have the apples. So the chicken and apples are going to equal 7. So bye-bye F. And that one I want there for it. Now the other thing is, if you had seen that before, that's also the same thing that happens on J. The problem with J is that you want the money amounts. So when you want the money amounts, you want the money amounts attached to each of those pieces. So H ends up being our answer. Here, if we're looking at equations, easy one to go for is my slope-intercept. So my y-intercept is 0, 0. I can count from there down to right 3, down to right 3. Equation of y equals -2/3 x plus 0, but I don't have to write that part because that ninja number is out. With this one, I have a vertex, which means I can write vertex form. So here, my vertex is 0, -2, which is H and K. I want to check the A value of it, so I'm going to check the next pretty point. I have a distance of 1, so my A value is equal to 1. So it allows me to write y equals 1, so just ninja 1, x minus, I don't even have that parentheses on there. I can take that parentheses out, because if I'm doing x minus 0, well, then that's just x squared. And then minus 2 for the k. So that was me using my vertex form. So a x minus h squared plus k. All right, here, parallel, we're looking at same slope. Perpendicular, we're looking at the flop, so flip and opposite slope, and neither just means anything else. So I've got to get slope. So the main thing is, what are the slopes of these two equations? So I want to get them into slope-intercept form. So with the first one, divide by 4, y equals 3/4 x minus, and then negative 4 divided by 4, negative 1. So there's my first slope. Then I go to my second one. I want to get y by itself. So I'm going to subtract 4x on both sides. 3y equals negative 4x minus 6. We'll divide by 3. And I get y equals negative 4/3 x minus 2. So again, I'm looking at my two slopes. So when I look at that, I want to see, are they the same? No, they're not the same. So then I want to see if I flip the fraction and it's the opposite sign. So 3/4 to negative 4/3. Yep. So this one is perpendicular. Okay, 16, domain and range. Domain deals with our x values. So I'm looking at the minimum, maximum, the high and low of your domain and range. So I'm looking at the lowest possible x value, which is right here at negative 4. And then my highest possible is over here with 8. And I've got a dot that touches, so they're both equal. So then my domain becomes negative 4 is less than or equal to x, which is less than or equal to positive 8. For range, I'm talking my y value, so I'm looking at the y-axis. My lowest possible y value is all the way down here at negative 8. And then I'm going to go up as far as I can, and I'm not going to stop at that negative 2. I'm going to keep on going to the very, very top at 8. So I know I've got a dot there. Here, though, if it's touching it, I can add a dot in. So those are both also equal. So then I have negative 8 is less than or equal to my y values, which are less than or equal to my 8. Okay, with 17, we've got a ray. So I'm still looking at my x values. I still want to try to find my low or my high. Here, though, I keep going down and down and down and down, so I don't have a lowest point. But I do have a highest point. And there, I've got an x value of 1, 2, 3, 4, 5. So I have an x value of 5. And every other x value is getting lower and lower and lower than that. So then I have x is less than, and it's touching it, so less than or equal to 5. When I look at my range, same sort of thing. My lowest y value is right there at negative 2. When I start to go high, I've got this arrow again. So it's going to go up and up and up and up and up and not stop. So then it's getting greater and greater and greater and greater and greater with all my y values. So then I have y is greater than, and it's touching, so equal to negative 2. On 18, again, low and high. So at my lowest x value, I can go all the way to there. Now, I can't actually touch it, so I'm going to put a dashed line there because I can't touch it. It's not equal because that little thing says, I'm not touching you. So my lowest x value is negative 6. And then I go as high as I can, and I get to that positive 3. So then my domain, -6 is less than but not equal to my x values, which are less than or equal to the +3. When I look at range, same sort of thing. I go to my lowest point, which again is that same open dot, so it is not equal. So my lowest point is -2, but it's not equal. Then I go as high as I can, and there it is at +6. So then my range becomes -2, less than my y values, less than or equal to my +6. Okay, so 19, we want it parallel to the x-axis. So I kind of want to think about what in the world my x-axis looks like. So my x-axis is a line like that, which means it's a horizontal line if I want it parallel to that x-axis. I want to pass through the point 3, 7. And I want to know the equation and the slope. So that's going back to Hoy. On my horizontal lines, I want a y equals equation. So I look at that y letter. So my equation becomes y equals 7. My slope, the O in my Hoy, tells me that I have a 0 slope.